There are many pathways in the endocrine section, and today we are going to talk about several pathways that are involved in the releasing and the stimulating hormone pathways because they are very important and they are quite complicated to memorize and to understand. So first let's talk about the three major hypothalamic pituitary axes that involves the releasing and the stimulating hormones. So first we have the HPA, which is the hypothalamic pituitary adrenal axis, and then we have the hypothalamic pituitary thyroid axis, and then we have the hypothalamic pituitary gonadal axis. We're going to focus on the first two, and after that we are going to focus on a slightly complicated releasing regulation for growth hormone. So first let's talk about HPA. So HPA is involved in the adrenal gland. So what happens is we have stress and we have circadian rhythm. They both contribute to the stimulation of the release of CRH from the hypothalamus, which then activates the release of ACTH from the anterior pituitary, which then stimulate the release of cortisol from the adrenal gland. And then we have HPT for the thyroid hormones. So what happens is that the hypothalamus would release TRH, which then stimulate the release of TSH from anterior pituitary, and then it would stimulate the release of T3 and T4, the thyroid glands from the thyroid hormones from the thyroid glands. And these two pathways, the HPA and the HPT, they both feed back in a similar way, in the sense that cortisol would feed back to anterior pituitary to inhibit ACTH, and it would also feed back to the hypothalamus to inhibit the release of CRH. And similarly, T3 and T4 would inhibit TSH and TRH release. So these two hypothalamus and these two anterior pituitary. So the result is that the endpoint would inhibit both the anterior pituitary and the hypothalamus from releasing the relevant stimulatory or releasing hormones. A keynote for HPT is that somatostatin also inhibits TSH. Now let's talk about growth hormone. Growth hormone release is quite complicated in the sense that it is controlled by two neuroendocrine secretion systems, which is the GHRH neurons and the somatostatin neurons. So what happens is that we have somatostatin and we have GHRH. They do opposite action in activating or inhibiting GH. So the SS would inhibit the release of GH, and GHRH would stimulate the release of GH. And what happens is that GH would then activate IGF-1, not activate, like release in the liver and other cells. And what happens is IGF-1 would then feed back to inhibit GH and activate, stimulate the release of SS. And then we also have a GH inhibiting itself and also inhibiting GHRH. And one more thing to note here is that other than these two, GHRH and SS, there is also a third regulatory hormone, which is ghrelin from the stomach. Ghrelin regulates our hunger, our appetite, and what it does, it would activate the release. Would not activate. I always say activate. It is stimulate the release of GH. So for you guys to memorize, I would suggest that you memorize the stimulatory pathway and the inhibitory pathway separately. So if we look at the stimulatory pathway, we have ghrelin, GHRH. They both activate GH, and GH stimulate the release of IGF-1. And then we have to look at the inhibitory pathway, which is GHRH is inhibited by GH, which is then inhibited by SS, which is somatostatin, and IGF-1. Why? Because IGF-1 actually activates SS, which then inhibits GH, and IGF-1 would also inhibit GH itself. So, in conclusion, the inhibitory pathway would have GH, SS, and IGF-1. They all inhibit GH, and then GH would then inhibit GHRH.